Welcome again to Network Security, Firewalls, and VPNs. This is part 2 of Lesson 1, Fundamentals of Network Security. In this lesson, we will begin by discussing wired and wireless networks. In wired networks, the lack of external connectivity will create a physical isolation. You can rely on physical controls to protect the network, and external threats, therefore, must breach this physical barrier. If external connectivity is required, then no control is the same as physical isolation, but security must enable the business. You need to consider segmentation as well as rigorous front door screening, including filtering, multiple firewalls, and virtual private networks for remote access. Remember that connection to a wired network is limited to those directly attached to it. Physical isolation of a network requires one to physically access the system connected to the network or otherwise attached to it. However, the nature of networking is to connect networks to each other. Therefore, external connectivity should require segmentation and filtering. Of course, most businesses today use wireless networking to communicate, and there are benefits of this. A wireless network can be inexpensive to deploy because you don't need to run wires, and there's quick connectivity for multiple users. There's convenience involved. Users can move from one part of the organization to another or one part of a building to another and never get disconnected, which of course leads to mobility and ubiquity. All laptops now come equipped with wireless. But there are wireless concerns because it introduces a new attack surface, requiring additional design considerations to mitigate the attack, including MAC filtering, hiding the service set identifier, which can have its own issues, and authentication, which must be done to ensure that only those who are allowed into the network are allowed into it, that only those who are authenticated can access the network. Data is transmitted over the air and accessible, so you need to use encryption technology and consider implementing segmented wireless networks. You also should consider requiring VPN authentication for wireless access. The network can be directly accessed from a distance by shielding. You have to consider the business requirements, the availability of the network and its components. You need to include redundancy, and of course you have to have high availability, which includes active-active, active-passive, hot standby, and cold standby. A network you have to always try to avoid a single point of failure in a network, and you have to consider the denial of service attacks. The sensitivity of the data is going to require encryption, as well as access to control to ensure that only those who are authorized to access a resource can do so. Internet exposure. Remote access. Will VPN work? Is direct internet access required? A system that needs to be accessed remotely can add additional concerns. Accessing a system over a VPN connection will ensure that the system maintains much of the security associated with a corporate network. If a system requires a direct connection to the internet for users or customers, one may need to consider additional firewalls, the creation of a demilitarized zone or DMZ, or additional SSL encryption. Mobile networking. It allows the user to be completely mobile. Requires considerations for central management, though, and the potential for the device to be lost. Corporations and organizations have allowed employees to bring their own devices into the workplace. This concept, often known as BYOD, or bring your own device, can be of a great benefit to the organization because you don't have to pay for the device or the connectivity, but at a potentially great security cost. Besides data being lost when the device is lost, the commingling of personal and organizational data can become a security nightmare. Other concerns like access and encryption must be considered in a BYOD policy. Common network security components used to mitigate threats. You have to remember that you have hosts and nodes that have to be secured, whether you're going to run IP version 4 versus IP version 6, firewalls that could be employed, VPNs, proxy servers, and NAT or network address translation. routers, switches, and bridges, the domain name system or DNS, directory services, and intrusion detection systems and intrusion prevention systems. All must be considered. TCP/IP networking, the OSI reference models. Here we see a slide that depicts TCP/IP networking on the left-hand side and the relationship to the OSI reference models on the right-hand side. So the network interface includes the physical and data link layers. The internet is the network layer. The transport is the transport layer. And in between that and the application layer in the TCP/IP stack is the session layer, then the presentation layer, and of course the application layer at the very top, where part of the session layer relates to the TCP/IP application layer, and of course the presentation and application layers are included in the TCP/IP stack's application layer. The OSI reference model layers are the application layer at the top. This layer enables communications with the host software, including the operating system. The application layer is the interface between host software and the network protocol stack. The sub-protocols of this layer support specific applications of types of data. The presentation layer translates data received from the host software into a format acceptable to the network. This layer also performs this task in reverse for data going from the network to the host software. The session layer, layer 5, this layer manages the communication channel known as a session between the endpoints of the network communication. A single transport layer connection between two systems can support multiple simultaneous sessions. The transport layer, layer 4, formats and handles data transportation. This transportation is independent of and transparent to the application. The network layer, layer 3, handles logical addressing, IP addresses, and routing traffic. This is where your routers are located. The data link layer, layer 2, manages the physical addressing or MAC addresses of each device and supports the network topology such as Ethernet. This is where logical and physical switches are located. And the physical layer, this layer converts data into transmitted bits over the physical network medium, such as your Cat5e cabling. IP addressing. Assigned to computers for identification on a network. Internet routing uses numeric IP addresses, and the IP addresses are in packet headers. A packet makes many hops between the source and its destination. IP version 4 uses 32-bit addressing, and IP version 6 uses 128-bit addressing. Security countermeasures. Some common countermeasures in this table including the uses, the benefits, and limitations. Firewalls, of course, are used to filter traffic and segment subnets and networks. The benefits, of course, are that they can be included in hardware and software. They are the first defense often, and they keep noise out. The limitation is that it's not good for perimeter defense, not content-oriented, and limited just to yes or no. A virtual private network, or VPN, is used for remote access and used to create an encrypted tunnel between the internet or a web server and a network. The benefits are it's a private tunnel. It's private, and only those who are authorized to use it can use it. And it extends the cover of your security. The limitations are it's susceptible to man-in-the-middle attacks, and it's not traffic-oriented based on what kind of traffic is being transported across the VPN. Intrusion detection prevention systems, or IDS, IPSs, they do monitor traffic, may block attacks, and they can be placed on the host or network. The benefit is that they'll notify you when an attack is underway, typically by perhaps a text message to a smartphone, or maybe to a pager or some other device, and they can prevent attacks. But they do rely on signatures, and they often give false positives, and so those are limitations that have to be taken into consideration. Some more data loss prevention. The uses of data loss prevention is monitor data loss and block it. The benefits, of course, are sensitive configuration and breach notification. The limitations are it's signature reliant. It does give false positives, and you can circumvent it. Network address translation, or NAT, translates internal IP addresses into external public addresses, reduces the number of public IP addresses needed. So if you're still using IP version 4, it's a great benefit to employ NAT. The benefits are it thwarts hackers because they can't see the internal addresses, and again it extends the use of the IP4 addressing scheme. The limitations are requires IP forwarding and can make some applications difficult to run. Security incident and event management. It's used to aggregate security logs and correlate them. The benefits are you can monitor and review them, and it'll generate alerts. Limitations are it creates false positives, is data heavy, and there's a limit to how much log information you can actually store or access. Continuous control monitoring. It's used to check configuration, standard compliancy, and real-time monitor. The benefits are that it automates monitors and self-correction. Limitations are, with emerging technology, some methods become outdated, and it's heavily dependent on policies being written properly. Vulnerability assessments. They test your systems. The benefits are proactive addressing and centralized tracking. Limitations are limited to just what's known, and it often creates noise. In summary, this chapter has discussed the confidentiality, integrity, and availability mandates for network resource security, network security and its value to the enterprise, roles and responsibilities in network security, the impact of network infrastructure design on security, and the features, uses, and benefits of network security countermeasures.